Happy day and welcome everyone. Today we're going to be talking about titrations and specifically how to do calculations in titrations. And so given different lab situations, can we figure out what calculations that we need in order to come up with whatever that we're looking for, whatever answer we're looking for. So let's start off with the equipment in a titration. So very typical, we have a burette that's here and we've got our Erlenmeyer flask. We have a burette clamp, but we could use a double burette clamp. That's typically what I prefer using because then you can just pinch it and that opens and closes it once you have it screwed on to our ring stand. So then we have our ring stand. So inside of the burette, it is very typical to put a base. And inside of the flask, very typical to put an acid, but it could be flipped. And so you always want to look at your problem to see what the order is. What they call the substance going into the burette is typically called the titrant, whereas the analyte or the titrand is what is going to be in your flask. So let's say that I have an acid and I know what the acid is, and I'm trying to figure out what the concentration is of the base. A lot of times they'll call this standardizing the base before I end up using it for another, to try to figure out what another acid is. So I know my acid, and I don't know the exact concentration of my base. So what I'm going to do is I'm going to start, and you don't have to start up at the top, which does actually say 0, because that means that you've dropped 0 milliliters. And you don't have to start at 0, you could start at 20 as long as you know how much of the base you dropped. And so I always say, did you drop the base? And so how much base did you drop? And once you know that, that's going to be the volume that you're going to use as your VB. All right, so that's really important. We don't know MB, so let's say that that's what we're looking for. Okay, the volume of your acid is the volume that you started with, and the molarity of the acid is obviously MA. That's the molarity that you started with. But sometimes they don't give you that. Instead, they say that you dissolved, and they don't even tell you how much water you put in it. You dissolved a certain number of grams of the acid. So if that's the case, instead what we want to do is we want to change grams to moles. Well, the nice thing is, so if you remember, anytime that you multiply molarity times a volume, so whether you're doing M1V1 equals M2V2, MAVA, or MBVB, it doesn't really matter. What you're essentially doing is moles over liters times liters, and your liters cancel out, and you're left with moles. So in a titration, what we're basically saying is, if we say that MAVA is equal to MBVB, we're essentially saying that moles of our acid are equal to moles of our base. So if I get rid of my liters, then moles of acid equal moles of base. And that's what it means to be neutralized. So neutral, remember, means the pH is 7. So if I can figure out moles, either doing it from using my molarity times my volume, or the other way to do it is I can convert my grams to moles using molar mass. How do we do that? So remember, all you have to do in order for that to happen is just convert using your molar mass. That's if you know what the substance is. And once you know that, both of these should be equal if it's neutralized. So the moles of your acid should equal the moles of your base once it becomes neutralized. So we're going to kind of use either one of these, and you can solve for really either one, MAVA, MBVB, in as long as you know a couple pieces of information. So let's take a look at a couple of problems here. So this first one says, you place 20 milliliters of an unknown NaOH. So I don't know the concentration of my NaOH. So I'm going to say that MB is what I do not know. So I'm going to circle that with a question mark. And this is 20 milliliters of it, which means it is my VB. That's my volume of my base. And I'm just going to underline that this is, and if you need to say that this is NaOH, then you can rewrite that if you want to. They put in a flask, they add a couple drops of indicator. So let's talk about the indicator. The indicator will change colors when it reaches the end point. So that end point is telling us when we have neutralized or reached what is called the equivalence point. So the end point tells us our equivalence point. Well, what is that really telling us? It's telling us that our moles of acid and our moles of base are equal to each other. So that is basically what a titration is doing for us, is getting to the end point to tell us when are our moles equal to each other. So you fill a burette and you have 1.5 molar HCl, so I'm going to call this my MA, my Ma. The color of the solution changes, meaning you have reached we called it the end point. And the end point, remember, is where it has become neutralized. Okay, so now it's neutralized. And that happens when you've dropped 28 milliliters of the 1.5 molar HCl. They're repeating that again. So they already told us it was 1.5 molar HCl, so we can ignore that. But we're dropping 28 milliliters of the HCl, which means this must be my VA. Okay, you always want to check the ratio. I've got NaOH and HCl. 1OH, 1H makes one water molecule. So it is a 1-to-1 ratio. So I can use MAVA equals MidVib normally. It's asking what the concentration is of the sodium hydroxide, which we already know. We already said we were looking for MB. It's a titration problem. So typically we're going to use MAVA equals MidVib. Okay, let's fill in what we know. So we know our Na is 1.50 molar HCl. We know that the volume of our acid is 28 milliliters. And that's equal to the molarity of our base, which is what we're looking for, and the volume of our base, which is 20 milliliters. Okay, remember easy algebra? So we're simply going to multiply 1.50 times 28 and divide by the 20. And when we plug this into our calculator, we get that the molarity of the base is equal to 2.1. I'm going to add one more sig fig, 2.10, and that's molar of the NaOH. Okay. They actually will tell you sometimes that it's about 2 molar. So they'll say your molarity of your base is about 2 molar, but we're standardizing it. So we're trying to figure out the exact concentration, or close to the exact concentration of the base. So in other words, the molarity of the base by titrating an acid using the exact moles or grams of it. So titrations are also used to determine molecular weight of an unknown acid. So now I'm going to show you a different way of solving this. So sometimes they'll say, what's the molecular weight? And so I'm going to give you a different way. And by the way, if you were given grams, like I was saying earlier, instead of doing this, so let's say I knew the grams of the acid, instead what I could do is I could take the grams of the acid and I could do a bridge here and change my grams to moles and use that entire thing as my moles of acid and then divide by 20. So you could do it that way depending on what type of problem you have, okay, or what is happening in the lab. Units of molecular weight, don't forget, are grams per mole. All right, let's flip. Let's take a look at the next problem. Okay, so this next one says you're asked to do an analysis on a newly found powdered substance with basic properties. One of the tasks is to figure out the molecular weight of the substance. So you dissolve 3 grams of it. Okay, so now they're saying 3 grams of it, but we really need to know what it is. So it's saying that it's basic right here. So I'm going to say that that's actually the base, okay, into about 100 milliliters of water. Anytime something says about, you cannot use that in a calculation. We cannot use about, okay? And you titrate it with 1.50 molar hydrochloric acid. Perfect. So same as last time. This is going to be my MA, my hydrochloric acid. And it takes 89.2 milliliters of the acid, so that must be my VA, to neutralize it. What is the molecular weight? Okay, so first thing I always like to do is, if I know I'm looking for molecular weight, I'm going to write the units that I'm looking for. Now, I'm going to put a letter B there because it is for a base. So I specifically want to know the grams of the base and per mole of base, okay? So I need to make sure that it's of the base. They told us the grams of base. That's right here, the 3.00 grams. So I already know that. So I'm going to fill that in. Equals 3.00 grams of the base, which I don't know what it is. I have no idea what it is. It says it's unknown. But now I need the moles. Well, here's the nice thing. If it's neutralized, what 2 things do we know are equal? Did you say that if it's neutralized, that means that moles of acid are equal to the moles of the base? If that's the case, if I can figure out the moles of acid, I know my moles of base. So in this case here, it says that we dissolved 3 grams. I already took care of that, but now I can see I have a MA and a VA. And if you remember, molarity times volume, which is moles over liters times liters, will give you moles. Exclamation point, exclamation point. Okay, so that gives us moles. So keep that in mind. Don't forget that. M times V, or molarity times liters, gives me moles. And make sure you're not in milliliters, okay? So I'm going to switch my milliliters to liters. I'm going to go 1, 2, 3 loops back. And so now I'm simply going to do MA times VA. So I've got 1.50 molar I'm going to multiply that by the volume of my acid, which is 0.08920 liters. So I ended up getting 0.1338 with 3 sig figs. I'm going to make that 0.134. Moles of acid and base. Why? Because it's neutralized. So once it's neutralized, then the moles are the same. Not the molarity, not the liters, but the moles have to be the same, okay? So now I'm going to plug this number in here, 0.134 moles, and do 3 divided by my answer. And 3 divided by 0.134 is giving me 22.4, roughly, 22.4 grams per mole. So then what you would do is, if you're given options, you could calculate the molecular weights of different things and check to see which one has a molar mass around 22.4. And usually there's going to be a little bit of error if you're doing a real lab, a real experiment. I hope this was helpful. Happy day to you all.